Imagine a world where one of the harshest, most uninhabitable places on Earth becomes the key to solving humanity's energy crisis. The Sahara Desert, a vast ocean of sand stretching over 9 million square kilometers, receives more sunlight in a single day than some countries do in an entire year. What if we tapped into that immense solar potential by covering the desert with solar panels? The idea sounds like science fiction, but it's a concept that has been seriously debated by scientists, engineers, and policymakers. The implications of such a project would be staggering, not just for energy production, but for global economies, climate change, and even the desert's own ecosystem. Could this be the solution to our planet's growing energy demands, or would it unleash unintended consequences that could alter the world in ways we can't yet predict? The sheer scale of the Sahara makes it an almost irresistible candidate for massive solar farms. With an average of over 3,000 hours of sunshine per year, far more than most populated regions, this desert could theoretically generate enough electricity to power the entire planet several times over. According to some estimates, covering just 1.2% of the Sahara with solar panels could meet the global energy demand. That's a mind-boggling prospect, especially as the world struggles to transition away from fossil fuels. Solar energy is clean, renewable, and increasingly affordable, making it one of the most promising alternatives to coal, oil, and gas. But the question remains, is such a project feasible? And if so, at what cost? One of the biggest challenges would be the logistics of building and maintaining a solar farm of that magnitude. The Sahara is not only vast, but also an incredibly hostile environment. Sandstorms, extreme temperatures, and a lack of water would pose serious obstacles to construction and upkeep. Solar panels would need to be constantly cleaned of dust and sand to maintain efficiency, requiring vast amounts of water, a resource that is already scarce in the region. Engineers would have to develop new technologies to make the panels self-cleaning or resistant to the harsh conditions. Additionally, the infrastructure needed to transport the generated electricity to other parts of the world would be unprecedented. High-voltage direct current, HVDC, transmission lines could carry power across continents, but building such a network would require international cooperation on a scale rarely seen in human history. Then there's the question of how such a project would impact the Sahara itself. Deserts may seem lifeless, but they are delicate ecosystems that support a variety of flora and fauna adapted to extreme conditions. Covering large swaths of the desert with solar panels could disrupt these ecosystems, altering wind patterns, shading the ground, and potentially changing local weather. Some scientists have even suggested that large-scale solar farms could influence the climate by changing the albedo effect, the amount of sunlight reflected back into space. The Sahara's light-colored sand reflects a significant portion of solar radiation, while dark solar panels would absorb more heat. This could lead to localized warming, which might, in turn, affect rainfall patterns not just in the desert, but in distant regions like the Amazon rainforest. The interconnectedness of Earth's climate systems means that even a well-intentioned project could have far-reaching and unpredictable consequences. Despite these challenges, the potential benefits are too enormous to ignore. A Sahara-sized solar farm could drastically reduce global carbon emissions, helping to mitigate climate change. It could also provide a stable and abundant energy source for some of the world's poorest regions, spurring economic development in North Africa and beyond. Countries like Morocco and Algeria, which already have smaller solar projects, could become energy superpowers, exporting electricity to Europe, the Middle East, and Sub-Saharan Africa. This could shift geopolitical dynamics, reducing dependence on oil-rich nations and fostering new alliances. Moreover, the construction and maintenance of such a project would create millions of jobs, offering economic opportunities in regions where unemployment and poverty are rampant. Of course, the idea raises ethical questions as well. Who would own the electricity generated by the Sahara? Would it benefit local populations, or would it be controlled by foreign corporations and governments? Historically, resource extraction in Africa has often led to exploitation rather than prosperity. Ensuring that the wealth generated from such a project is distributed fairly would be crucial to avoiding further inequality. Additionally, the land used for solar farms might conflict with the needs of indigenous communities, such as the Tuareg people, who have lived in the Sahara for centuries. Their rights and livelihoods would need to be protected in any large-scale development plan. Technological advancements could make this vision more achievable in the coming decades. Innovations like floating solar panels, which reduce land use, or solar paint, which could turn any surface into a solar collector, might offer alternatives to traditional panels. Battery storage technology is also improving, making it easier to store and transport solar energy efficiently. Some researchers have even proposed combining solar farms with agriculture, a concept known as agrivoltaics, where panels provide shade for crops, reducing water evaporation and increasing yields in arid regions. These kinds of hybrid solutions could make the project more sustainable and beneficial for local communities. Ultimately, the idea of covering the Sahara with solar panels forces us to think big about our energy future, our relationship with the environment, and the kind of world we want to build. It's a bold vision, one that comes with enormous risks, but also unparalleled rewards.